Yeah.
And we are live now. We're just streaming the poster right now. So whenever you are ready, Kaushik, do the switch.
Yeah, I think.
Let me share my screen very quickly as well.
Yeah, you can share your screen. We have it ready. And, cool. I think we are live. The audio is live too. Yes, Somo.
Okay, just give me 1 second. You guys can see, right?
Yes, we do.
Okay.
Maybe you can just we can make it full screen. All right. Hello, Dixon.
Okay, just let me know when we are live.
We are live. We are live, Mo.
Okay.
So
Okay. Hello, everyone, and thank you all for attending our November meetup. Next meetup will be the last meetup for this year, and thanks all for attending. And as usually, we always try to get you the best speakers from our community. And today we have very cool speakers. We have Saurabh, which is a senior software engineer in Blazeclan, and he will talk about AWS Redis Cache and API rate limiting. And we have Abdulsalam, which I think everyone knows him from the community. So he's a software architect at SEEKAsia, and he used to be the lead cloud as well in Seek and the team lead in iFlex. So he always shares very cool stuff when he used to work with iFlex, and now he's sharing what's happening in Seek. But today he will cover on the QCon Digest. So before we start, we have a couple of call-outs. Please mute yourself if you are not talking on Meet. And we have giveaways today for some AWS credits. So you have 2 ways to win these credits. First way is to answer our speaker. So our speakers will be asking some questions, and if you answer correctly, we'll give you AWS credits. The second way, which is you join our networking session after our live stream. So we will hang out on Google Meet, talk about anything related to tech, of course, and we will give you a feedback form to improve our meetups and our community. And if you fill up this form, we will pick up one of the guys who fill up the form, and you will win some AWS credits as well. And now we will start with our first speaker, Saurabh. Again, he's from Blazeclan, and he will share with us about AWS Redis Cache and API rate limits. So I will pass it to you from here, Saurabh.
Hey, thanks, Alamat. Okay, just I'll share my screen.
Yeah.
Let me know once you can see my screen.
We can see. Yeah.
Okay.
Yes.
Okay, amazing, guys. Hey, hello, everyone. I hope you are all doing great and fine in this tough situations of COVID. And working from home is all good for all of us working. And also, hello, everyone, to all the Facebook Live people and all the people wherever they are live. Okay, so today's topic is a bit interesting and bit about how we can secure our APIs and keep them healthy, safe, and secure, just as we are keeping us in our tough situations. So now, as the software industry demands, like our softwares are increasing in terms of the load and the capacity and the hits, and so we need to make sure that our APIs are working fine and they are in a very safe environment, and they are not down with someone doing a hack or someone doing a brute force attack, or they are not intending to use for the what specific purpose the API was built to use, right? And so this session is all about how you can secure your APIs while doing a rate limiting. And there are different ways and algorithms to do it. And every big companies right now these days are doing this, right? This was a big trend in coming up in the years, because now Facebook, Twitter, Instagram, or anyone, they expose their APIs, right? You can load the feed, and then there are costs associated with the number of the times you can call with the APIs. They have segregated into free tiers, like, okay, by this much tier you will be associated with this much cost, and so forth and so on. So the session is all about that, how you can rate limit your APIs so that your APIs is not intended to use what it is not for meant for. And on top of it, how you can use a layer of Redis cache to increase the overall efficient and performance of the system. So before beginning to it, just a few lines about myself. I work as a senior software developer in Blazeclan, Malaysia. I'm a certified AWS solution architect professional, and in my free time, I love to do sketching. Here, I work for one of the largest media conglomerate, and my primary responsibility is to handle their entire payments. So they are the biggest in Malaysia, the media company, and I work as a consultant for them for their payments domain. So basically, my forte is that payments, online payments, and the payments notifications to the CRM, and so forth and so on. This is something about me. And before I start the presentation, I would like to say that anyone has any doubt at any point of time, just please stop me at that instant, and we can discuss and discuss further. Okay, since I am not visible to you, I'm sharing my screen, so I can't see the presentation right now. I'll not be very much visible, but I want this presentation to be interactive, so that at the end of the day, at the end of the presentation, I feel that okay, we took something out of this. And I've tried to keep this presentation in a very light mode. So let's just go ahead with it. Okay. Okay. So what is our biggest fear while managing a production system? Okay, especially at the time of the deployments, right? We have an existing code base which is running fine in our production system, but at the time of release, we push something and it breaks, right? And as your system is growing, as the traffic is increasing, as your environment is becoming more and more stable, any new code or any new push, you just fear that, oh, tonight we go on production, and if anything breaks, if my APIs did not work as intended, if there is a high CPU utilization, and which is ultimately leading to my 5xx errors and all those problems. Because I have faced this problem personally in my systems, so I can say that, okay, this was every production release was a nightmare for me, because I have a stable code running, which is tested and thoroughly, but to push anything new brings the chills out of me. So this is my biggest fear while managing a production system. It ultimately, see, the traffic in the systems are increasing exponentially, right? In my current system, if I started the system with almost, say, 5,000 transactions in a month. Now 5,000 transactions in a day, right? And now if I compare it with the capacity which I'm dealing with is 40,000 transactions in a day I'm dealing with, right? So my APIs are able to accommodate, my system is able to accommodate without breaking a sweat, right? So because there has been control checks point at every level, which makes sure that my system is up and running. And when you are actually going to throttle your APIs where it is not working as expected, then you need to check and investigate why it is not working. You check your slow running queries, you check your DB indexes are proper or not, check your API response time, and you see that everything is working fine or not, because you have exposed an API and there is a specific capacity to be to define it consumed. And there are various use cases, right? You can't expose your API just for a brute force attack, because ultimately your API is interacting with your database to get the data, and each DB calls is actually a hit on your system. So you need to make sure that your APIs are well within your defined ranges and they are consumed properly. And obviously, we are supposed to make the API faster, not slower. If the APIs are slower, ultimately the whole traffic gets choked down and my production is down, which we don't want, right? Now, what to do now, right? So bug on production on Friday, but we can't go home, right? We have to solve that purpose. So here comes a very beautiful concept of API rate limiting, where we made sure that our APIs are working as efficiently as possible with a specific amount of load. But suddenly we saw that there is a sudden huge traffic and my APIs are not working as it's supposed to be, and I'm getting a fatal error. It can be any of the issues, right? So because nowadays we are all working in a serverless model, where my APIs are behind my API gateway running on AWS Lambda, and they're intended for a specific load. But if someone is just exposed to API and it keeps on hitting it, then ultimately my hits are increasing, and it is increasing my cost, right? So these are few of the factors for which I want to implement this API rate limiting thing, right? So what is this API rate limiting whole about? API rate limiting is that you define a certain specific time frame that within a minute or within 5 minutes or within 10 minutes, this API can be consumed only this many times from a specific user or from a specific URL or from a specific ID. Anything from a specific thing means I'm associating it with a specific ID, a user, or a URL which is not changing, that it can consume this thing only this many times, right? If this thing is asking me more than that, then I'm not gonna entertain your request. I'm not gonna serve your purpose. So this is the whole broad line of API rate limiting, which every big organization, Netflix, Instagram, Facebook, anything, any organization you do, they are securing their APIs by API rate limiting. Okay. So this is about API rate limiting, right? You can't just dole out unlimited access to your API. You are essentially handing over your keys to the kingdom. Anyone who can use your API, they want any time. So rate limiting is a critical component of product scalability, and there are a few rules by GitHub and LinkedIn for the developers to maintain sure that how you can implement rate limiting in terms, right? Now, what are the ways of API rate limiting? Okay, so first is request queue, second is throttling. These are two ways by which you can hold on your request. And then there are rate limiting algorithms. There are four algorithms which I have mentioned here: leaky bucket, fixed window, sliding log, sliding window. Just to take a pause, is my pace is correct? Am I audible correctly? Fine, everyone?
Yeah, it's good. It's good. It's great. Right? Yeah, sounds good.
Amazing. So, okay. So request queues are basically you are queuing your request. Okay, you queue your request and then you are slowly and steadily entirely processing your request queues one at a time, right? You are not actually exposing your APIs to throttle at one time, but you are not losing requests, but you are handling it via queue. But again, there is a limit with a queue also. How much you can hold it in a queue? SQS v4 has a request, I guess, has a liability of 300 requests in some specific period of time, which you can extend, obviously, but how much, right? That's the number, how much, right? Then there are throttle. Throttle means you just ignore the request anyhow. Anything comes, you just ignore it and you let your system to be down. Now, specifically to handle these scenarios, there were defined few algorithms like leaky bucket, fixed window, sliding log, and sliding window. So I'll try to explain in a nutshell what this algorithm does. So I'll just do what is, I'll draw a whiteboard. Okay, is my whiteboard visible, guys?
Yes. Yeah, we can see that.
Okay. So okay, leaky first is leaky bucket. Okay, so first algorithm is leaky bucket. Leaky bucket, basically it's a bucket kind of a thing in which you have like slots like this, and you have your requests coming up, pouring up in the bucket, and you save the request, and you process it one by one from here, right? So leaky bucket will have a capacity, say 10 requests, and it holds 10 requests at a time. So say here it's 1, 2, 3, 4 requests it holds. After that, anything which is 5th request or my 6th request will go out of the bucket. We will lose those requests, okay? And meanwhile, it is processing. So if first gets processed, then the second one comes down, then any 7th request which comes will be entertained here. So this is the whole idea of leaky bucket, that you have a bucket, and out of that bucket can hold how many requests, we will process it. Meanwhile, anything which comes beyond that will get out of the bucket, we'll lose those requests. Meanwhile, the processing of the buckets goes on, and if a bucket has space, we will accept your request. If not, then sorry. So that's the whole agenda of leaky bucket. Okay, let me erase it. Clear frame. Okay. Now, second is fixed window. Okay, fixed window is what is that you define saying that I can entertain in my API, say 10 requests per minute. I'll only take 10 requests in a minute. Okay, so you defined a kind of a like a timestamp saying that at 7:14 minute, I'll associate with the counter. So this goes with a counter with a 0, and with each user ID. So the key is like this: user ID is there along with a timestamp, and then there's a counter associated with it. It can be anything unique, not necessarily user ID, whatever you can identify as a uniqueness in your system. It can be user ID. For me, it was a payments based system, so I associated with a payment reference ID or my transaction ID, which is a unique for it. So anything which is unique associated with a timestamp and with a counter. So at say 7:15, I got a request with one ID. I'll just increment this counter to 1. At 7:15, I got this request for the same ID with the same timestamp. I'll append this to 2. And I will keep on appending this till 10. After that, any more request which comes here with the same timestamp and the same user ID, I'll not entertain. Then I'll say, no, sorry, you have exceeded your limit. I have to be available for my other parties and other users, so I can't entertain you. So this is the concept behind your second algorithm, which is the fixed window, that you define your window that it will take only this many requests in this many time. That's it. Above that, I'm not going to entertain you. And this is the one which we have implemented in our project, and I'll show you a live demo of how it works and everything. So we have maintained a counter and everything. Now the problem came with fixed window is that supposedly you have a define in a minute saying I'll serve only 10 requests. Okay, so you have defined that minute. Now it is 7:16, right? So at 7:16th minute, in the 55th second, in other interval I didn't get any requests, but in 55th to 60th second I got 10 requests. So I served those 10 requests because my limit quota was allowing me to serve those 10 requests. But at 7:17, as my 7:16 got over, at my 7:17 it started. Again in 5 seconds, I got again 10 more requests. Ideally, I should serve those because another minute lets you allow another 10 minutes. But the problem with this fixed window is that within the frame of 10 seconds, say 7 hours 16 minute 55 seconds to 7 hours 17 minute 5 seconds, within the frame of 10 seconds, I am blocking my API with 20 requests at instantly, which so I'm taking the numbers very gradually less here. It should not it will not say impact it much, but say on a very large scale and you are defining some rate limiting. So this is actually blocking your system, saying within a very less period of time, you are hitting the system with 20 requests, right? Which is not expected because I have defined 2 minutes for those 20 requests to be entertained and absorbed, right? So this was the problem with fixed window. So they came with the third algorithm, which was the sliding log. So sliding log did what is that they just maintained an array. Okay, so they just did something will help me. This one. So they just maintained an array, and they kept the request holding here. Each request goes inside the array, and every request they are not maintaining any counter or anything, but they are defining saying that only 10 requests can be served in a minute. Okay, so every request goes in an array. It comes here, it comes here, it comes here. Now when I am processing, when my system is processing or when my API is processing, it checks, okay, what are all the requests which is within 1 minute. So out of say all are there, right? 1 2 3 4 5 6 7 requests are there. It says, okay, fine, 7 requests within a minute I can process it. My quota is of 10, right? But if you keep on increasing it and the array length goes beyond, right? So it goes beyond 11, then it stops entertaining your 11th request. It will say, no, dude, I can only serve 10 requests. I have this capacity. And every time it goes to queue to check, it first filters. Give me only the request which is within 1 minute. Otherwise, I'm not going to entertain you. You are already expired. So just go out of my array index. Okay. So this was the thing with sliding log. Now, problem with sliding log, or not, I am not saying problem with sliding log, but it was not memory efficient, because every request, putting it into a queue to manage that queue was a bit challenging. The problem is, like, say, currently it's 719. 719 a request came, I put it in a queue. 719 another request came, I put it in again in a queue. 719 another request came, I put it in the queue. Now this is creating problem for me, because every request I'm putting it in the queue, it's not memory efficient. To make it more memory efficient, fourth algorithm came. What was the sliding window? Sliding window. Yeah, the sliding window did what? It also did the same concept. It maintained an array, but the beauty of it was that it maintained a counter with a timestamp. So what it did, it was not putting all the requests in a queue separately. So all the requests, so for example, currently it is 720. So 721 request came. So it hold the timestamp 720, and it maintained a counter slash say 1. If any more request comes in 720, it will just increase the counter 2. Anything with the seconds also, sorry. There was seconds associated with it. 720 minute with 00 second. Anything comes, okay, 1. 720 00 second, anything more comes, 2. No, if the seconds move on, then 720, say 5th second, 1 request come, I maintain the counter 1. If any more requests come, increase it in the same second, increase it in the counter, right? So I'm not, with every request, I'm not increasing the length of my queue. Whatever is clubbing it in my 1 second request, I'm grouping them all together. And and processing remains same for the API to it, right? API checks whatever is beyond the limit of 1 minute, exclude them. Otherwise, it will just count it. Okay, this is 2, this is 2, this is say 5, 5 to 7 to 9 plus 1. Okay, 10. 10 is my quota. Okay, I'll process this many requests. Otherwise, I'm not gonna entertain any more requests. Okay. So these are the 4 algorithms which are defined for our API rate limiting. Okay. Now come the next section. Okay. So a lot of talking. Okay, I know this, that. Now let me show through the code. Get me through the code. So this was what we did in our project, in payments project. That we used annotation, and I did implementation of fixed window bucket, where I was storing each request with their specific ID, with a counter associated with it in my database or Redis cache. Wherever you want to store, you can store, and after a specific period of time, you can just delete those requests, because Redis has a timeout period. After that, it goes off. So Redis is a very beautiful use case which came here, that I'll store everything using my annotations around, and I used AOP, aspect-oriented programming. So I bound it across both the functions, in and out. So any request which used to come into my API, used to first go and talk to my rate limiting API, increase the count, make an, if there are no entries in my entry in my Redis or a DB, it will make the first entry of it. If the same request comes again, it will increase in it. It will keep on increasing in it till the time I have defined, okay, I will serve only this much for you. Okay, so this is something like annotations max request limit, how many you can define, and invalidate after how many times. Okay, so to show you something. Okay. Okay. Okay, so I have my program and everything running. I'll just show you a demo of it, how I have done in it. I'll just create a transaction for it. Okay, I use Postman to do it, and then I go here. I just say, okay, this is my ID. Just copy this, go here. This is my what is this issue with it? Okay, should not be the case. Okay. Okay, just a different environment. Okay, this is serving my payment page. Okay, so this URL is working fine for me, right? I just hit this URL and I'm getting a payment page to display. Now, what I'll do is, since this is exposed to my partners and everything, now someone does a mischief, right? He keeps on hitting this URL again and again, right? And there is no threshold associated with it and everything. But he can't do, right? I'll stop him because so in front of you, if I do, what I'll do is I'll increase the traffic for this via my command prompt, and I will just use this and we'll change here. So actually I am doing a load of 100 requests in a minute, which I'm putting on my server right now. So once this is executed, then any more request which comes here, so it has been executed, right? So if I try to hit it now, ideally I should not see the result page, payment page, right? Because it got blocked. Because so what I did was I have this concept saying that this page can be opened with a specific ID until only this many number of times, right? If even beyond that, I can't use it. So any more time I hit, sorry, I'm blocking you. I'm not no more serving your request. Okay. So this is the thing, right? If I do it again, I'll just create one more ID here, and if I just try to paste, it opens, right? Similarly, if I append this URL and I keep on do a traffic load, say let's do it of this is there. Let me just paste it for you, and I change the number not from 100, so I make it say 40. So ideally, the case is that my payment page still should open because I have the rate limit of 50. Right? Let's see if it opens or not. Okay. Now, if I go here and I do a hit again on this, it opens, right? So it has incremented the count to 41. But if I keep on hitting it again 9 or 10 times, then after that, say 3, 4, 10 times, then it will stop serving my request any more time, right? And again, this has a expiry of validity of, say, you can define it 1 minute, 5 minutes, 10 minutes. After that, this all gets cleared, and if you try to hit it again, you'll able to serve this page again, right? So that's the beauty of it, right? You are actually controlling the usage of your API. How many times do you actually want to use it and get it exposed to? Okay. So yeah, that's a bit of thing, and there's a code annotation which I have actually written for this thing to serve. just to give you an idea about it, saying that every request comes here in the handle limit request, and I get the URL. Then I check is valid for proceed. Basically, check whether I am okay to proceed ahead with my request or not. If it says yes, you are valid and you are well within your limits and rights to proceed ahead with it, go ahead with it. If not, then okay, sorry, I can't serve your purpose anymore. So yeah, that is all about rate limiting and everything. Now, while exploring this rate limiting, demo it. I don't believe you, but I did demo it. Okay, so yeah, it's so amazing, right? But while exploring this entire rate limiting thing, and while we were facing this, because we were facing these issues in our system, that we were actually choking up our database with so many calls and everything. So we identified that there are so many unnecessary calls, right? And we have to stop those unnecessary calls. So while we explored this entire rate limiting thing and everything, we also got this beautiful thing called AWS Redis Cache. So Redis is basically open in-house memory service, which was an open source. AWS provides their own elastic cache service in combination of memcached and Redis. So we have used AWS Redis, which is the in-memory caching, and so it does amazing things for your system, right? If you can identify those portions which are not changing very frequently, and which are all your like just configuration or anything you want to show on your something like on a Facebook, you want to show your notification feeds, your main screen feeds, and if you don't have internet connectivity, how does Facebook still manages to show you feeds? Is because it's caching, right? It caches entire thing, and now the entire, I guess, software industry believes in to cache as much maximum as you can to cache it up, right? So this will ultimately reduce our DB calls, will reduce your DB efforts, will reduce your API response time, and will give you very quick results and responses. There's a very beautiful thing to use AWS Redis. We use it in our system, and we have found a drastic improvement in our response times and in our APIs. So what we did was that we have identified those portions which are not constantly changing or changing very rarely, and we put everything in our all those parameter stores to Redis. So while the project loads or it gets boots up for the first time, everything is entirely present in the Redis. So my DB is all fine, not a single sweat it is going on the servers, and everything is amazing for it. And how did we understand is that how did we did it is just a single annotation. It's a very simple to implement. Cacheable, you just name which cache names you want to segregate, because you might be having different projects, right? So based on your project, you can identify, give the keys to it, and then you can store it in a thing. So we used Spring expression language for creating and maintaining keys, and their values were stored in Redis. And Redis also gives you this flexibility of encryption your entire data, so there is no security thing, and everything has been taken care of by AWS very nicely on those fronts, right? And then the best part is it has a TTL. So anything which you don't want to persist for a long time, but for a very short time, you associate a TTL for it, right? And that does wonders for you, right? So this was just the graph of how the system was behaving when the Redis was not there, and how the system drastically changed when we implied Redis on our systems. Okay, so just to give you an idea how do we use Redis. So I can't exactly show the actual performance of Redis and everything, but if I show you, so from a Postman kind of a thing, then this cache. So if I say get keys from my Redis transaction API, and this is my dev environment, and I just say send. So these are all my keys which are there stored in my Redis. Okay, so all my configuration, all my quick checks, all my checks before doing a transaction, and everything has been stored here. All my property files, property readers, and everything has been stored there. And it's very simple to delete keys from Redis. If I did anything, I restarted it and delete, just a single API call, delete the keys. Again, when you hit the API, If you don't find a key corresponding to your Redis, it will hit your database and will get the data and will maintain a copy of it in the Redis. So it's so easy. And then you are exposed via these APIs from AWS, where you can clear your keys, where you can clear your caches, and you can do so many things with the Redis, right? So that's one of the things with it. Okay, then bring back here. Okay, that's too fast. Yes, getting everything from Redis only. Wow. I guess you might be having a lot of doubts. So over to you guys. Can we ask questions?
Thank you so much, Saurabh. I really like the memes, man. It was fun.
Thank you.
It was fun to. Okay, let's see the chat. If anyone, Abdulsalam, if you want, you can turn on your mic and ask him directly.
Yeah, sure.
Nice.
Thank you. Actually, I have a question related to benchmarking Redis versus DynamoDB DAX.
Mm-hmm.
Yeah. Have you done any kind of benchmarking to?
No, actually, I haven't used only DynamoDB, but I know it's a document-based DB, which is very fast, right? Which is actually meant for your, which is like a soulmate for your serverless designs. So I've read blogs that if you're designing a serverless designs where you are expecting any increased fold load, then DynamoDB is your best solution, and they work like magic for anything. But I haven't done any benchmarking on that.
Can I jump in to answer that?
Yeah, sure, Fabian. Go ahead.
So just if you're actually comparing Redis versus DynamoDB DAX, it's never so much about the performance, because I think the difference will not be much. It is the main reason why anyone will actually go DynamoDB DAX over Redis is due to simplicity. That means you're already using DynamoDB, and you want to add a caching layer so that you can manage your costs effectively, at the same time get that enhanced performance. That is actually the primary reason why anyone would actually go with DynamoDB DAX. And ultimately, both are actually using caching as well. So, but it still doesn't change the fact that from the number of hops you need to make, like for example, let's just say you're using Redis, right? It's still one call away. If you're using DynamoDB DAX and then you already have that caching layer in place, that is also one call away. So performance-wise, usually there isn't much difference. It's due to simplicity.
Okay.
Cool. Thanks, Fabian. Any other question, guys? We have. Okay, I think then that's it. Thank you so much.
Hey, hold on, man. I have questions.
Sure, go ahead.
By the way, I saw Muhammad Faris asking a question.
Where is it? On YouTube or?
It's on chat. Yeah. Saurabh, you want to go for that?
Yeah, sure. Right. Let me see my question.
Oh, yeah.
For an unauthenticated public API, how would you determine parameters for rate limiting? So it's not about authenticated or unauthenticated API. It's about you have to identify. For example, if you just identify like Cloudflare or DDoS attacks, they just block if you are hitting your URL too many times, right? But if it keeps on constantly changing, they also can't stop that request and everything. So you have to identify in your URL on the APIs that you can associate it with something, some user ID, some ID which is constantly being hit in a specific period of time, again and again. It's not about being whether that API is authenticated or unauthenticated. Is that the call which is being made is from a specific user or from a specific IP or from a specific region, which with a huge amount of traffic and a load, and then you block it. Then you define the parameters. It depends on your set of params which you are expecting in the request payload. Sometimes it can be a very simple GET request, which I showed you was a GET request, which was rendering a page, right? You can have a very simple GET call, which is just getting certain database records from the DB and showing it on it, right? We have so many just status calls, GET transaction result. Well, I can relate it because I'm from the payments domain, so to get a real example, these are my APIs, which keeps on getting so many hits, right? But with each request, I have something unique in the request itself, which identify, okay, anything which comes with this ID, with this timestamp, sorry, I'll serve it only this many times. Apart from that, I'm not going to serve. So it's not about authentication or authentication, but you have to identify what parameter you can define for that thing. I hope I answered your question, Faris.
Okay, my
Fabian,
turn.
it's your turn.
Yes, so my turn. So, Saurabh, I really enjoy listening to your sharing around different kinds of algorithms, data structures actually utilized for rate limiting. Question for you is, it sounded to me that you were actually implementing this manually, like using obviously code. And I'm aware that there are quite a number of managed services that actually handle this. So how do you actually make a decision, whether to actually handle this on your own or either to rely on a managed service, like for example, AWS API Gateway?
Okay, so when we did an exploration of it, our APIs were hosted on EC2 servers. Okay, so which is the network route is something like that. You come in a domain, behind your domain you have a load balancer. Between that domain and load balancer, you might have a Cloudflare or WAF or something. And after that thing, it comes to my EC2 server. So the whole rationale of using an API gateway eliminated then and there only for the security. If it was anything behind my Lambda or something, I would have explored those options. I'm not sure if EC2 instances also I can use some sort of API gateway in front of it to handle the security front. So when we were exploring this, we went through a lot of blogs and articles how these companies are doing it. And then we went through Google's docs and Netflix and how they are securing LinkedIn, how they are securing their APIs. So we found that this is a general trend which the company follows to secure their APIs. So that was the rationale of going behind this, of doing it via code portion.
Got it. Only reason why I actually ask this kind of questions is managed services obviously takes off that heavy lifting, like figuring out all these things. Obviously, from a software engineering standpoint, I really enjoyed listening to that. The only question right now is like how long did it actually took you all to build that? And just a call out, AWS API Gateway does actually provide the private feature, where you can actually deploy that directly within your VPC. So just a call out.
Okay, that's we can explore that option. So the API gateway I can use is behind my EC2 servers also, Fabian?
Not behind. Definitely, if you're talking about compute, a place where your application runs, the API layer has always to be in front, and then your applications are actually behind that.
Okay, so it doesn't matter whether they are the APIs are running on EC2 or Lambda, right?
It doesn't really matter. Yeah, it doesn't matter.
Okay. Thanks. I got one more question. What is the best direction to implement fog computing with some kind of algorithms to enhance the performance of fog in the aspect of time latency? Sorry, I did not get this fog computing. And just someone elaborate, light it up. Are you there in the call? Yeah. Hello, light it up. Can you just unmute and you can ask this thing? Good.
Yeah, light up. You can just ask directly if you want. Okay. Maybe he has some issues.
Okay. Yeah. Any questions, guys?
I actually have one more.
Yeah.
So you mentioned earlier that the API is actually on EC2. And in most circumstance, if you have a distributed application or a larger application and you implement a API gateway pattern, you would have like a API layer, right at the front, which is exposing, whatever backend systems that you actually have to the internet. So question for you here is, would there were there any considerations between utilizing something like GraphQL versus REST API, or you didn't need to go through that consideration? It was more about just saying that, hey, I think exposing this service via REST API is actually the way to go forward.
Yes, so you answered it in your question itself, that I didn't consider of GraphQL and other things, because so what I have also seen is too many services without doing of intent of doing anything. It's also creates a problem for me, because you have to maintain it also, right? Just not even if they are managed services, but I still have to create a record. Okay, this has been used here, this component has been used here, and as you go along and increase the number of services, it actually builds the complexity around it, right? In my system, I started with very less, but right now, the number of the lambdas which are running, if I have to make a count of it gets really difficult, right? To make a consolidated board, okay, these are my running lambdas and everything is fine, because again, you have 3 different environments to maintain. You have dev, stage, and production. If each environment has 80 lambdas running, then ultimately you have 240 lambdas running in across 3 environments, and which is breaking where creates a trouble for me. So I try to intend to use the means, not the best, but which I feel, okay, this can suit my purpose, and rest I can handle it via my code and everything. So yeah, that's it.
Okay. Just a connecting question to that. Sorry, last one. Yeah, I know.
No.
Yeah, Moana sometimes will say, "Hey, Fab."
No, go ahead.
Interrogation.
We don't have a lot of questions.
You brought up Lambda earlier. You were speaking about EC2. And I just trying to understand the landscape of your application here. Is it a mix between Lambdas or EC2, or is it EC2?
It's a mix. We have
awesome.
both servers also, Lambdas also. So whatever we do synchronously, we keep it on servers, and whatever the async functions, we just shoot it to the Lambdas to do their duties and perform the tasks.
Nice. Okay, cool. Thank you.
Thanks, Fabian. Abdulsalam saying that we should have a rate limiting for Fabian. Wow. Okay, thank you, Fabian, so much. And Saurabh, thank you.
Yeah.
So let me just share my screen very quickly. Okay, so today we don't have any hiring announcement, but if your company is hiring, please scan this QR code and fill up the form, and we will announce this hiring announcement next meetup. So let's help the community and people who lost their job to find a new opportunities. And now we will jump again to Fabian, who is always sharing what's happening, cool stuff with AWS. So I will pass it to you, Fabian, from here.
Okay. And let me share my screen. Share now. All right, awesome. I'm just gonna move my browser across, and is everyone able to see my screen?
Yes, we do.
Yes.
All right, awesome. So let me kick off. So thanks so much for having me today. Again, so good to see everyone here. And allow me to give a quick introduction for those that do not know me. So I'm Fabian. I am a senior solution architect. I've been in Amazon for over 7 years and have been in many different roles, from software development, big data engineering, systems engineering. In the past, one of the biggest secrets is that not many people know that I used to be an electronic engineer for at least 3 years, and got booted out because of the global financial crisis in 2008. So many years ago. So I started out as an electronic engineer, for those folks that did not know. So from time to time, you may see me dropping some comments in the AWS user group Facebook wall. So if you have any questions, actually, in fact, just a major call out, feel free to drop questions there, because I do have a look, and we do actually have a very active community that is actually willing to jump and respond, should you have any inquiries over there. And so I'm here with you all. It's just to actually share what are the latest updates. And another major call out I want to make is that this coming Monday will be the first day of AWS reInvent. And for those that do not know what AWS reInvent is, this is basically our largest educational event that we host on a yearly basis. It all consistently starts usually at the first week of December, and it will last about 2 weeks. So for the first time, we're actually running this for 3 weeks virtually, which comes to my next point here is that if you're keen to learn, like the latest updates, products, or even where AWS wants to go, do register yourself, and it's free, absolutely free. And once you register yourself, you get to see the agendas, and you'll see a lot of exciting topics. So I've been here for quite some time. I went through the agenda. I can tell you that my eyes was actually seeing stars. It was so much content. And so if you're actually from the machine learning background, you have interest in analytics, you have interest in IoT, you have interest in application development, you name it, right? You will be able to find it there. So it's a lot of interesting topics there. So as usual, I will cover the feature releases over the past 1 month, and I will not cover everything because there's just too many, in fact. And as I prepared quickly, this deck this morning, I was seeing stars again myself because there were that many new features. So I actually scoped this down to at least 8, probably 7 to 8, and the way how I actually go about picking it is actually based on the companies or the folks that I work with in Malaysia. So I try to make it as relevant as possible. So talking about relevance over here, right? This is actually not a technical feature. This is essentially a startup activate console that we launched and it's made available on the AWS Web Console. So if you go to a web console right now, you just type up startup, you actually see this. And what this essentially is, just give me a moment here. What this essentially is that if you are an aspiring founder and you actually need help, it's as simple as just applying for support, as in credit support with AWS. Now, however, if you are a company that is already backed, by some kind of VC, venture capital, you can actually get more credits. So all I'm trying to share you over here is that this is more for awareness. Is if you have any friends, if you know anyone that is actually aspiring to build something, have already deployed a workload on AWS, and then typically what happens is that they struggle for funding, right? Lead them to this. It's as simple as just going to the web console and then just applying for it. Yeah, you don't need to actually reach out to folks like me, okay? And straight away you get connected to a startup rep from AWS. Second one, this is actually very exciting for me, and primarily because the version 2 JavaScript SDK was published as a single package many years ago. And when I said many years ago, I believe it may be in the range of easily 5 years. And at that point in time, we didn't have that many services. Probably we were ranging at 60, 70 services. So why this modularized JavaScript version 3 SDK is exciting to me is because if you are a front-end developer and you import the version 2 SDK and have your customers or your users download it, it will not be a great user experience because it is bloated. There's a lot of different services that's actually packaged within that, and a lot of times you don't use it. So what happens here is that while working with some really established startups in Malaysia, they will tell me is that how do I solve this? Like we want definitely, we want to deliver a great customer experience, right? So we end up leading them to places like utilizing date code elimination techniques, and some of you may actually hear tree shaking. And there are tools like Webpack, Rollup, that enables date code elimination. It's just that it requires you to learn, another tool. And earlier I mentioned, AWS is all about simplification. We want to make things easier for you to adopt because we want you to go faster. We want you to build things that is actually relevant. So this JavaScript SDK is already in the release candidate stage, modularized, and then you can pick whatever you want. So do check it out. I really look forward in the next couple of months seeing it go live. And this has been in development for over a year. I think easily 2 years. Another tool I just want to call out, the Amazon Pinpoint, which is basically a user engagement tool to enable marketers, developers to deliver customer-centric engagement experiences. And before this, Pinpoint was already deployed, in other regions such as the US, the European regions, and also in Tokyo. It's just that it was never in Singapore. So what Pinpoint essentially provides is that it packages up not just engage how you go about creating a user journey for your customer, but it packages up push notifications, emails, SMS text messages, voice messages, and so the whole idea is that you can bundle it, with other AWS services. Let's just say like AWS Personalized, which you can do recommendations. So imagine now, not only can you actually engage your customers effectively using omni-channel approaches, but also at the same time being able to personalize content for them. So you have any kind of user engagement use cases, check out Pinpoint. You don't need to actually go in and learn what SNS is. You don't need to learn what SES is. Pinpoint actually packages and bundles all these things together. For analytics tools, Kinesis, for those that don't know, it's a real-time analytics ingestion service. And one of the major limitations I always hear consistently is that a Kinesis stream, while it's actually designed for real-time analytics and real-time processing, and because of that reason, Kinesis was initially designed only to retain 7 days worth of data, and customers say that that's not good enough. So just a couple of weeks ago, we released this feature. Now you will get the 1-year data retention. Now, the alternative to Kinesis streams has always been the managed Kafka. For you, a lot of businesses these days are actually using managed Kafka. And I get a question, how does this actually compare to Kinesis stream? Just to make a quick call out, is that Kafka, you have full control. However, you still have infrastructure to manage. Whereas Kinesis stream, very similar to Kafka, is purely serverless, but at one point, 7 days retention, but now just bear in mind that it's 1 year data retention now. On the second point is that we also enable direct integration with DynamoDB. So any kind of changes, let's just say that you are a heavy DynamoDB user, DynamoDB is NoSQL database. And if you make any kind of changes, just imagine that you can actually stream this, directly to Kinesis, and you can do real-time analytics on that. So it's a very powerful tool. If you're building a data lake, you can use Kinesis to actually deliver the data directly to S3 as well. So check this out, if you are a DynamoDB user. Next one, this is the one I'm most excited about, Managed Airflow. So this has been an ask from many customers for a couple of years. For any data engineer, that is actually building a data-driven pipeline, or they would actually prefer to utilize, like a industry standard orchestration tool, like Airflow. The unfortunate thing is that we didn't provide that, and what happened here is a substantial number of businesses, that run their workloads on AWS and ended up deploying that on EC2. So all I just want to say here is that that problem is gone. It's really easy to implement or deploy Airflow in your account, and this is actually available in Singapore itself. I've tested it; it is fantastic. Yeah, very, very straightforward. So another feature I just want to call out, which hasn't gotten much visibility, it's CloudWatch synthetics. And if this is the first time you're hearing about CloudWatch synthetics, I will tell you that this specific function went live, as in generally available 6 months ago, where CloudWatch synthetics is essentially a service that is part of CloudWatch to simulate how a user navigates your environment and tells you whether is there a problem. Okay, and for those of you that is actually in the UAT testing world, Selenium is actually a typical tool that you actually use to run your user acceptance tests. All I'm going to tell you here is that with this specific service, if you were to use this, you can run periodic UAT tests, using canary scripts where a user navigates your websites, and if there's any problems, you get alerted. So quick examples of canaries that you can deploy using synthetics: heartbeat monitoring, just to know whether is there any problem with your URL. Do you have broken links, on your website? And do you have an issue with your APIs? So very, very easy to use. And the primary highlight that I wanted to share here is that now you can use Python canary scripts. Before this, it was purely, if I recall correctly, it was JavaScript. So compute release is another one. Spot instances, and who doesn't want to save money? Everyone definitely wants to save some money here, and what they end up doing is that they end up buying savings plans, or they end up using on-demand instances, and then they do a start-stop with a scheduler. A lot of times what I've seen is that customers that want to use spot instances, which is about 10-20% of an on-demand rate, struggles with that. And the reason for that is that spot instances, if someone actually bids the price higher than you, that instance gets reclaimed. Okay, that means you can lose this instance at any time, and that's the challenge with spot. But at the same time, people still fight for it because they know they can get an awesome rate. So all I want to call out here is that we have launched a rebalance recommendation feature as part of
Fabian?
Yep.
Okay, I think it's a bit not clear.
Okay.
Is it only me?
Okay.
It's still breaking for me.
Yeah, Fabian's voice is breaking. Yeah.
Oh, okay,
Okay.
even.
Okay. How does it sound now?
Yeah, now it's good.
Can I sing for you, and then you just tell me, whether I'm breaking? Okay. All right. So I think everything is okay, right? The fact that you're laughing there. All right, let me continue, right? So
Yeah.
if you rely on spot instance because you want to save costs, and you are facing with the dreaded 2-minute interruption notice, and when I said 2-minute interruption notice, right? You are only given 2 minutes to react to this. I can tell you that you can use this feature immediately, because what happens here is that when this feature actually comes in play, the EC2 auto scaling will rebalance or will replace your spot instance with another instance proactively. That means you don't need to put some kind of reactive script to manage that. Okay, so I just want you all to be aware of that. Check that out. Check this thing out. I think this is actually a really, really good feature, especially if cost optimization is a priority for your business or for your company. So this one, this is going to be more of a quick one, just to let you all know that RabbitMQ is actually available now as a managed service on AWS. Questions I sometimes get, it's like, why is Amazon actually launching a service like this, And I just want you all to know that Amazon, AWS does actually offer quite a number of messaging services. You think about SQS, our simple queue service. We have Amazon MQ for ActiveMQ. So there is quite a number of queuing services already, messaging services. And the only reason why we launch services like this is so that customers can benefit from managed service, so that they can actually focus on meaningful work. So RabbitMQ, the managed RabbitMQ, is actually compatible with your open source RabbitMQ, and so for any business that want to migrate over to the managed RabbitMQ, is actually rather seamless. So if your business is actually using RabbitMQ, you have specific features that doesn't allow you, to move to serverless services like SQS. Check this out. And finally, actually, I still have two more. Second last one. This is more for container developer experience, and this tool is called Copilot, and it's designed for existing Elastic Container Service users and new users who want to simplify container application development. And if you are a long-time user of AWS, you will come to realize that building containers on AWS actually takes quite a lot of effort. You think about building designing your VPC, your load balancer, security groups. There's quite a bunch of infrastructure-related matters to think about. So what AWS Copilot intends to do is to abstract that all away. We want to give you an end-to-end experience. Let's just say that you are just intending to build a prototype, and you don't want to learn every single AWS building block. Check this tool out. It handles provisioning. It handles deployment. If let's just say that you are looking for an easy way just to test out your prototype, and you want to include, like a NoSQL database like DynamoDB, it's all there within the CLI. Okay, and on top of that, it also includes operational related features, like being able to extract logs just to know, whether do you actually have any issues, with your containers. So in a nutshell, this tool, while I said it's simplification, the second thing that we want to focus on is that, so that when you go about, you're thinking about your prototype, you want to build something, while you're doing your whiteboarding and you have your architecture, this tool enables you to focus on architecture, not on infrastructure. Final slide here. And this is actually for the Kubernetes users. For any EKS, Elastic Kubernetes Service users, if you have already been deploying your containers on EKS and you intend to expose your pods, your Kubernetes pods, to the internet, or to the internet, you will be very familiar with this term called ALB Ingress Controller. All I want to call out here is that we have expanded the ALB Ingress Controller capabilities and renamed this entire feature to AWS Load Balancer. And the kind of additional features that we have added to it is that now not only does it support the application load balancer, which is essentially a layer 7 networking load balancer. Now we extended this also to the network load balancer, which actually means that you are not confined to layer 7 restrictions anymore. You can build applications that doesn't just rely on HTTP. You want to use a completely different protocol, and so now you can do that. The second point is the fact that when you're actually using the AWS Ingress controller before with EKS service, for every single Kubernetes namespace that you create, you have to create, you have a single ARB like associated to this single namespace. With this new feature, a single ARB can now route requests to multiple namespace. So what this effectively means is that you can drive your overall cost down, because for every single ARB that you deploy, it will cost you a minimum, if I recall correctly, $25 a month, whether you use it or you don't use it. Okay, so just imagine now if you have a Kubernetes cluster and you have 5 namespaces, that essentially means that you need 5 application load balancers before. But now this restriction is going away. You can actually have one single load balancer for these separate namespaces. So this is all I wanted to share. There is in fact actually a lot of more new releases as well. And do sign up for reInvent, and there's going to be a ton of new services that will be launched. And that's all for me.
Nice.
Thanks.
Fabian, I have just one question. When is the PartyQL with DynamoDB integration will be available in Singapore? I was like excited for this for so long.
Genius question, man. I intentionally didn't include that slide in because it's not available in Singapore. And then you asked me that. Yeah. In fact, I don't know myself. I have to find out. And if that's actually a need for Astro, definitely we can find out for you.
Nice, because just to share with the guys, so this is a new feature which will allow us to do like SQL queries on DynamoDB. So basically now what do? We stream it to Kinesis, Firehose, then to S3, and we use sometimes Athena for reporting. And this feature will help us a lot, like doing cool stuff using SQL things. Okay, so another thing, Fabian, related to the Spot instances, right? Are you familiar with the website called Spotness?
I am familiar with Spot.io, but not is Spotness or Spot.io?
This is the new name. I think they changed it to.
Really?
Yeah.
Okay, I'm not familiar with that. Okay, I didn't know they rebranded themselves.
That would be actually very nice if AWS can do something like this out of the box, or you don't think so?
Yeah, I think what Spot.io. Okay, so Spot.io. Okay, yeah, Spot. Now they're known as Spot because they got acquired by NetApp. Okay, yes. I think it's very similar what AWS is actually trying to do. It's just that it's definitely more managed. I know for a fact, and they Spot.io, for those that's actually not aware, is that you are able to use Spot instances for many different kind of compute services. Let's just say that you are ECS, like you're doing container services. And so what Spot.io can essentially do is that while they're trying to reduce their costs, at the same time, they think about that context that you are trying to run a container. So effectively, they just make the experience more seamless. Whereas on AWS side, while it's actually really cool that we are trying to simplify Spot instance management and provisioning, on the AWS cloud. However, a lot of times we may not go to this detail. We are getting better at it. It's just that I think you can't really compare to a solution provider that's just focused on spot instances. And yeah, and their business model is such that when they save you money, and that's how they actually earn. So it's a very different focus, but definitely AWS is actually getting better at it.
So this is exactly what even Spotinx used to do, right?
I mean, behind the
Spotinx from bidding your for bidding the spot instance and so on and so forth, helping you give the right bid. Spotinx, is that a feature?
Yeah. This is the one. This is the one we are talking about. Correct.
Yeah.
Spotinx, correct.
Okay. Actually,
so this is very cool. Actually, like in Fav, actually we run on production all spot instances before. So basically, we saved like more than 80% of our costs, and we run everything on spot instances. It was really cool. So you guys can check it out.
Yeah. I actually I saw Salam's comment. You want to take the whole company out of business. Actually, that's not really the point, man. In fact, right. If everyone can use spot instances, I think that is a super major big win, man, because you're really getting more value out of every single dollar you spend. So if you haven't actually explored spot, right, please do so. I think it's really, really good. There is some complexity that comes along with it, but definitely worth your time.
Okay, thank you so much, Fabian. It was really. And hopefully we are going to do a reInvent recap as well. So we are syncing with Coaching and Salam to see how we are going to do this after the reInvent.
Absolutely. Okay, cool.
Okay, so, thanks, Fabian.
No worries.
And again, guys, if you have any question you want to check with AWS or anything, you can leave a post on our Facebook group, and we have Fabian or us, the community will answer you. Okay, so next. Okay, so you guys, if you want to give a talk or share what your company is doing or what side projects you are working on, you can share it with us. And if it's your first time, please just contact us and we can help you with creating the slides and work with you on how you can present. So even if the talk is very simple, we would love to host it in our meetup, right? So we want all the talks to be different levels. So please scan this QR code and fill the form and share the cool stuff with us. Next, again, we have Salam. Salam is he's very involved in the AWS community, and he's helping us as well in organizing this event. So he's responsible of streaming all of this to Facebook and YouTube, as he was an expert with videos and worked with iFlux for a couple of years. So let's welcome Salam, which is working at Seek at the moment. And I will pass it to you, Salam, from here.
Thank you, guys. Thank you. Could you stop sharing so that I can share?
Yeah.
So I'm guilty of having around 100 tabs open. Let me search through them to find the right one. Hopefully you can see my screen right now.
Yes.
Awesome. So hi, everyone. My name is Abdulsalam Alshallah. You can call me Salam. I've been here in Malaysia around 5 years, right? 5 years plus. I worked in many companies here in Malaysia. The latest of them would be iFlux and then SEEKAsia. In SEEKAsia, I moved from being a lead cloud architect in SEEKAsia only to be a solution architect in Seek. And right now I'm continuing with that. So some of the websites which you might know, which I work on, would be JobStreet and JobsDB, right? So my topic today is a little bit generic. There is no deep technical implementation, I would say, right? I'll be speaking about technicality here and there, but I won't be speaking about one topic only. I'll be speaking about my experience attending something called QCon Meetup, right? So QCon is one of the, you can say, biggest in the industry meetups. And this kind of meetup happen every year in many areas around the world. This year, they did it virtually. Me personally, I get a lot of cool stuff attending some of the recorded video for QCon. So this year when it came up, I just went to my company and asked them if I can join that meetup, and they were really, really helpful, and they bought me some tickets, and then I went there and today I'll be speaking about some of the things I observed in the time I spent attending QCon. So to give you some kind of generic idea about the type of topics and the type of speakers, usually you have many depth talks, right? So you have something like people speaking about GraphQL Federation, or something like data pipeline from many great companies. So Netflix, GitHub, GitHub spoke about how they transferred from having a monolith on Ruby to having microservices and their plan and also their migration. You have people from Microsoft, Tesla. They presented very cool stuff about how they are collecting data from different sensors, whether it's in cars or in the station where they have the chargers, and many more companies with which you have great people coming and speaking about how they are dealing with technology this day. The topics this year, you can say it focused towards senior engineers and also cloud architects, or sorry, senior engineers and solutions architect. The topics, you could say that they are focused into 3 buckets. The innovators, so people who like to go and learn about new stuff. For example, WASM, WebAssembly, right? And how people are trying to maybe run some very, very old stuff like C++ application, run it on Chrome. That's via compiling it via WASM, for example, right? So the topic of WASM was one of the innovator talks. And then also the early adopters is focused toward people who adopt technology at a very early stage. One of the top things that I've heard about here was the GraphQL Federation for me, and also the micro front ends. And then the early majority is for them, when you have, like, let's say the biggest startups and the biggest, tech players starting to use some of the technologies, like, for example, Kubernetes, it's somehow old for a lot of startups, but still for a lot of enterprises, they haven't started yet, right? So this is about their early majority representation. Now, the things I want to focus on today are mainly about what I heard about microservices and what I heard about something called paved road or paved path, and something about GraphQL Federation. Now, a disclaimer, I'm not presenting any marketing data, right? So I'm not marketing for anyone. And also, this is just a personal opinion about what I see the technology in the next 5 years will be focusing on, right? For sure, if you look at microservices right now, many companies and many startups are using microservices, right? But then the trends between a company and the other is really, really different, right? So if you have not started doing microservices, right, you will get a lot of people coming to you and saying, like, my application is already working. Why should I move to microservice, right? You have this kind of conversation. So actually, right now, I'm hearing from many people in the industry that it's okay not to go to fully microservices at some times, right? The need behind moving to microservices mostly should come from how your team is structured and also how your team is collaborating with each other, right? There is a lot of companies which still have a monorepo. So moving to microservices is not, the silver bullet that will solve all your problems. Sometimes you need to go and focus on, on something that is more productive for your case. If you want to go and move from microservices to, from monolith to microservice, then GitHub was speaking about their journey, and the highlights from them, which I really like, is that they focus on enablement. So they want to unblock their engineers. That's why they focus on the pieces where they feel that there is, tension, there is, many maybe downtime, or you could say conflicts, right, between updates and modifications. They also, in a lot of places, they thought that maybe it's not time to go to microservices in everywhere, right? And they started with the core services and any shared resources. And in addition to that, they started small. They didn't go, very wide on their whole system, and they followed, like, a value-based thinking. So whatever is the value that you are providing to the customer, you might take that and start working on it. Start working on the microservices for that piece. there is something very cool to consider. There is something called cap theorem. So the cap theorem is a concept which says you can't get every good thing out of microservices, right? Because in a distributed system, you have, let's say, network, right? And then you have the partitioning of the network, and you have two things in addition to that, the consistency and the availability. So if you take one of those, right, you are left only with one other. So you can only get 2 out of 3. This is the idea. And that's like theoretical concept. Like you cannot get consistency and availability and then also get, application that is tolerant with network failure, right? You choose one of those. You choose 2 of those 3. Now, one other focus that I've seen is that people starting to get attached more to the metrics of their underlying infrastructure, and mainly about a few concepts here, like mean time to failure, mean time before failure, mean time to discover, mean time to recover, and mean time to failure, right? So the main idea here is that those 5 things highlight how your application is running and operating, right? So if you want to understand correctly how your system is behaving, you will need to get some sense of of its MTTR or MTTA or this kind of stuff, because this is something that touch the users and touch the customers that you have, right? So for example, mean time to recover means if your application fail, right, then what is the time before your team being able to recover it and have the failure resolved, right? So it's something that maybe you will need to measure. And actually, on measuring, many companies are right now focusing on the observability and how they are doing it. In fact, there is very, I would say it's still early. It's like 1 year-ish, but there is something very cool that I see coming, which is open telemetry. I feel that it will be a standard for many things, right? And many companies have started using it and also integrating it, both from the consumer part, which is developers, and also from the visualization and reporting part, like Datadog and Dynatrace, right? So the main idea is that there is a standard of how you monitor your infrastructure, monitor your code, what is the logs format, the tracing format, and the metric tracking format, how you are sending it over to the to outside your application, and how other consumers, like let's say Datadog, is consuming your metric and displaying it and reporting on it, right? So it's a very cool concept. One of the cool things that was also presented by, if I'm not mistaken, it was Airbnb, but I'm not 100% sure, is how they improved MTTR by reducing the complexity of their solution. Sorry, anyone? Is there a question? I don't think so. Okay. By reducing also the specialization of the tools they are using, and by reducing the number of tools and increasing the ability to improve these tools they are using. Now, in my opinion, what are the services that helps you going into microservices world from AWS? I think Fargate is something that people should start using. I know that many people are excited to use EC2 instances and then Spot instances. In fact, Fargate also has Spot right now. And also, the cool thing with it is that you don't manage the underlying host, right? So you just run your container, and you don't care about anything else, because AWS have a set of SLAs to protect your running application. The other thing is AKS. I think there is a fusion of AKS and Fargate that is coming soon, if I'm not mistaken. Maybe Fabian later can shed some light on this, but I think I've heard of it. And also Lambda as a compute infrastructure for running your code. There is also application load balancer, SNS and SQS, for decoupling your microservices and having integration between them. API gateway, as mentioned in the earlier talk, is one very cool solution to have a gateway in front of your compute and in front of your APIs, right? So you have a RESTful API. You can have usage plans and rate limiting and API keys on API gateway, and that simplify your architecture. CloudWatch is a cool way to monitor your application. Many companies still prefer to go outside CloudWatch just because there is more sophisticated solutions out there. But I think CloudWatch is improving day to day. AWS Elasticsearch and ALK is being used for observability. So rather than going and also having like Datadog or having Splunk, people are using Elasticsearch running on top of AWS ES to log and observe their infrastructure.
Hey, do you mind if I just make one quick comment, right?
Sure.
Since we're actually talking about microservices, and this is actually a topic I'm quite passionate about. So what Salam has listed here is actually the list of services that enables the use of microservices. But earlier, before this, what Salam has actually brought up as well, is he talked about reorganizing teams, and that is actually one of the key criteria of rolling out, a distributed application in a microservice architecture. So my experience of that is that is actually really true. In fact, right, just to share with everyone for everyone's benefit, my personal opinion is that this identifying the technology to enable microservices is actually the easy part. But the tough part is more about defining the bounded context. Let's just say that you have a monolith, you want to break that down into different subdomains, and then you have microservices as part of that. That is actually a very tough exercise and can take a lot of time. And then the second part is how do you reorganize your team so that you can establish accountability to own, the microservices along with the subdomain. And I think this is the part where most businesses or companies will actually struggle with, So this is a major call up for that is if you're actually planning to go to microservices, you really do see the need because you want to go faster. You want your teams to operate in a more loosely coupled manner. You want them to operate in an autonomous fashion. Microservices that can definitely get you there. It's just that probably like whoever that has done microservices before, you'll be great, if you can actually share your experience specifically on the part where you define bounded context, how you reorganize your teams, and how do you identify the right patterns to create resilient inter-service communication among all these microservices. So I think those 3 points that I just call out is actually the toughest part, when you're actually thinking of going to microservice. Salam, yep.
Yep, thank you for the valuable information. And actually, one cool thing that you mentioned is that there is something called Conway's law, right? And it says that wherever you build follows the shape of your current team structure, right? So yeah, actually, I think it's very good to go and understand this exactly in a good way before starting to decouple your microservices, because otherwise you will have a lot of tension. Yeah. The other really cool topic that was mentioned, or actually it's not a topic by itself, but it's a way of work, right? I've been exposed to it in iFlix. I've been exposed to it currently in Seek, and it's very rewarding experience. So if you have a lot of developers, let's say, and you want to make their life easy, then the paved road or the paved path is a concept that is very cool. You can follow it. It's not directly technical. It's more organizational, and it also can help you with your microservice journey. The main idea here is that, let's say right now there is this DevOps spark in the industry, and everyone is looking at the DevOps term and how they could become more DevOpsy, right? Then they go and form a team, and then that team become the ops instead of DevOps. Because yes, they could write code, but then they are the bottleneck for any other request or for any deployment to go to production. So that's one of the bad ways that is happening right now based on this way of implementing DevOps, right? A better way is when you go and build a self-service solutions or self-service tools And this is the idea of paved road. So a paved road is where you say, this is, doing the right thing is very easy, and doing the wrong thing could be a little bit more complicated. And to do the right thing in an easy way, there is a specific team which build an internal self-service services or tool chain, or let's say internal open source, and then provide it to your customer, which is the developers in your company, right? So the customer in this case are the developers. Usually, I've seen people extracting the common issues. Like, let's say you want to set up a deployment pipeline, right? Setting up the deployment pipeline is, again, the same thing. You need to go to your GitHub. You need to go and create a webhook. You also need to authenticate with GitHub on the build agent. And then you need to take all this and, link it somehow, report on it. So the whole thing is, the same thing between every team and every project you have. So why don't you take this common denominator, build it in a standard way, make it one click away from your customers, which are the developers, and then, life is easy for everyone, right? So you extract the common issue, you solve those issues independently from each others. You deliver values often and regularly by saying, let's say, you want those people who are your customers to trust you, to trust that you are making their life easy. So let's say your developer want to roll out microservices. Now, let's say you decided that there is two ways of implementing microservices. One of them worker mode, the other one is API. Now, for your worker mode, you say everyone will be using maybe serverless or AWS SAM. You try to make the way of launching a serverless application very standard. You make it like an internal boilerplate or something like this, and then you train people on using it, which should be easy, right? And then people start trusting you so that you can roll out a next application. Let's say, how you run API on Fargate. You could make the whole thing also a standard, an internal standard in your company. So gaining trust from people is very important. Gaining trust from your other developers is very important. Now, to gain trust correctly, I think that you should not own or block any kind of production workload, right? So you should build an open source tool, right, internally for your team, provide it to them, and then you sit on the side. You are not someone who blocks them from pressing deploy to production, right? Yep. And last of all, I think automating and reducing reliance on people is very important thing. You don't want people always to come to you. You don't want the developers to come to you and ask you, hey, how can I, like, I need to approve this pull request, right? It's nonsense. Like, if you have an internal open source, the best person to approve this person, pull request would be one of his team, right? So structuring your GitHub and structuring also the collaborator on your GitHub correctly is something that is worth doing. Now, some of the ideas and some of the application I've seen Paved Road team taking care of is build pipelines, anything related to common GitHub operations, like even pull request, creating pull request could be something that you say, okay, I have a standard. Every pull request will be linked to Jira, for example. It have this kind of template. It have this kind of automated tests running on it. Like, it could be one of the things that you could also take as a common denominator and build it separately. Any common provisioning or deployment actions. Also, in addition to all of this, any chat ops or GitOps actions, right? Now, yep.
So just to add on that slide as well, I really enjoyed that slide because this is if you think about what AWS is, it is the AWS is actually similar, in that's how AWS actually came about, like over 10 years ago. Is more about how do you actually enable your developers to operate autonomously, and being able to deliver products fast, without having that kind of dependency. So AWS was actually inspired by that, before Amazon.com actually released AWS. So just think of it that way. And Paved Road, just thinking about what Salam has actually shared, right? A couple of organizations I work with, that have actually decided to adopt this approach what they end up doing is that they adopt like a cloud platform, like the AWS cloud, and they build guardrails, processes around that, so that developers end up consuming, the cloud resources in a consistent way that aligns with how the organizations intends to manage security, costs, reliability. So essentially, that's what my view, what the paved road is. Salam, any comments on that?
Well, I think this is valuable information as well. Maybe one concern, right, on the paved road in general, just before I close, because I think some people are thinking of it right now. If I standard every way, if I make everything a standard, then where goes the innovation, right? So this is the cool thing. Like you should have this kind of gray area. Why I said that the paved road team don't own stuff, right? But they provide internal open source, because you need to give your developers this kind of freedom of experimenting. Maybe you have like EKS and you are using Fargate, and some of your people want to go and experiment with EKS. Should allow this so that you can have like a learning and innovation in your team. Yeah. Cool. Yeah, as Fabian says, like security is one of the gains you could get here, because once you have this kind of standardization, it's very easy to implement any kind of policy or any security policy on this. Well, relatively easy, not very easy. AWS services that I think could help you with building a paved road, you can say offering, is CloudFormation for sure, or CDK. So whatever you prefer. I played around with CDK. Also, some of the teams I work with, they really love it. It's really cool. If you haven't used it yet, just take a look at it. It's like building your infrastructure as if you are programming or coding something, right? So you could have many cool stuff going on with CDK. Code pipeline, code build, code deploy, all three work together so that they could deploy, for example, microservices or deploy your code. So it's part of the standard things that you can set or build, right? You could build like a CloudFormation for deploying code pipeline, code build, and code deploy, and make that a self-service thing that your team use and invoke whenever they create a new GitHub repository. AWS Lambda is very cool thing, because like whenever you want to write this 2 or 3 lines of code which redirect or do any kind of modification or any operation, having Lambda makes it very easy to execute this and not care about many other things, right? AWS Chatbot and System Manager also plays very well with this concept, right? Now, the other topic that was really cool for me to hear about and listen and understand is GraphQL Federation. So maybe before I explain what is GraphQL Federation, it's something good to explain what is GraphQL. So you've heard Fabian in the first talk, he says, well, having maybe an API gateway or having a gateway like a GraphQL or AWS API gateway, something good in front of your services. So I think this is very cool idea, right? Whenever you have many microservices, instead of exposing a RESTful API from each one of them to your customer, and then have to deal with all the rolling update, all version management, all kind of rollback, maybe you could have like a gateway, right? So GraphQL could be that gateway. It's a query language for your API. Mainly, it gives you a few cool things, like you can edit your data, query your data, and also you can subscribe to data changes via a WebSocket. So you could have like an active connection between the GraphQL server and your mobile application. Whenever someone else change anything, you could see it on your mobile application. And actually, chat application with the GraphQL is very easy and simple to achieve. In fact, the first interaction between myself and AppSync was to build a small chat application with AppSync. So it's very easy. Now, it provides you a description of your data schema. So you have a central place which can query other microservices on behalf of your customer request, and then aggregate it together and then send it back to the customer. So it can cache. It can also show you a list of your schema, available schema, and also the data types and all this kind of stuff. And also it returns only the data which the customer requests. So let's say you have a user API, and this user API could return you 100 fields, right? And the customer asks only for an email and maybe an address, right? Then why do you return 100 things for him? GraphQL can make this very easy for you. You say, I want to query the name, I want to query the email and the address, and then it automatically fetch the whole thing, cache it on its site, on GraphQL server, and only return the data that the user requested. Another user come and request the same thing. If the caching is not invalidated, it will return the same thing for him. It acts as a gateway for accessing other data sources, as I mentioned. The AppSync implementation of GraphQL can connect to DynamoDB, Lambda function, Redis, if I'm not mistaken, and many other sources. It's a good replacement for versioning, in my opinion, but I don't think that it's the silver bullet that resolves the versioning issue. The cool thing here is that you could annotate some field and say that they are deprecated, and expect that you are returning the same data for the new and old fields, but then only new applications are running and extracting data from the new fields. So to a certain level, they say it could solve the versioning issue. I'm not 100% convinced. I don't have a very strong opinion toward this. So what I say is that you build many microservices, you decouple your system into many microservices, and now you put some GraphQL service in front of them. Isn't that building a monolith in top of your microservices, right? To a certain level, it's yes, right? But maybe what I'm going to speak about right now will change this idea a little bit. So you gain some stuff in having a single port to your microservices, a single point of contact, but you also gain many cool stuff by decoupling them, right? So using something like federation help you with this. And the idea is that you implement a single gateway for GraphQL, but you don't have your data schema on GraphQL here. You have your data schema delegated back to your microservices, and you have your microservices mainly owning main pieces of this data and extending these pieces of this data based on their needs. So the main idea is you have your users coming, as I said, to a central place, a GraphQL gateway, right? And your GraphQL gateway is calling a federated service, a federated GraphQL service, so that it can understand the type it supports and understand also the schema and all this kind of stuff that it can return. So whenever there's a mutation, it doesn't happen here. It goes called to here. Now, based on your architecture, you could have many layers of microservices behind each other if you want, or you could just receive the request and process it in this service. Now, I think that the federation as a concept is very cool. As I said, you split your GraphQL schema from storing it in the same gateway, and you take it to the service which own and actually can modify the data. Some services that can help you, I think right now, AWS AppSync does not support federation, but another cool solution is to run your GraphQL as a set of microservices, set of Apollo server microservices on top of Fargate, for example, right? Yep. Now I'm done. Is there any ideas or questions? I want this to be an open talk. If you feel that what I mentioned spark any idea with you, just bring it on.
And whoever will ask question, guys, will win some AWS credits. Or Salam, you want to ask the guys some questions and give them some credits?
I think I will receive questions. I have not prepared any questions.
Okay.
Sorry.
Okay, guys. So anyone who will jump for asking Abdulsalam question will win some AWS credits.
Actually, I'm waiting for questions. Like, I want to ask some questions. Recently, actually, I'm working on microservices for my company. So it's in a different hosting platform. As So what I'm looking at, why this is like starting of our microservices. Like I hosted 3 of the services right now. So the question is like how I can start on AWS, as a starting of microservice. What are the tools actually you suggest to look at?
I think one cool tool is what Fabian mentioned a few minutes ago, which is Copilot. So Copilot is a CLI tool that launch clusters on top of Fargate for you. And then you can say, okay, this is the Docker files that represent my microservices, and you deploy it via Copilot to a Fargate container or set of containers. It also, automatically scale for you and manage all the networking and this kind of stuff. So that's one of the options. I would go, one step back, and I would think about the type of workload that you have. If you have a workload that is not user facing, so this is my rules. Maybe Fabian will have a different opinion, but my rules are: if you have a non-user facing workload that has a lifespan less than 15 minutes, go to Lambda, right? If you have a user facing or something that could take more than 15 minutes to process, go to Fargate or to AWS Patch.
Okay, so it's a good suggestion. So one more question is what I was thinking of having Terraform to set up my cluster and all, because I will have to set up development environment, staging environment, production, and some of my customers, my company customers, they require like 5 environments: UAT, SIT, demo, a lot of things. So what I was thinking of having Terraform to set up the cluster, and then the each and every service deployment, I'm gonna use like GitHub Actions or something like that. So what do you suggest on this plan?
I think it's a good plan. Just based on my experience with Terraform, managing the states become very hairy, right? And become very complicated. So when you use Terraform, then you are building some plans, right? They call it execution plan, and then this execution plan being applied via another command. Now the execution plan, you can save it somewhere, right? Due to multiple versions of Terraform, right? I had a lot of issues with this kind of state. So I had like an old thing that I was processing and managing. Now I have a new, you can say, version of Terraform. I want to update the state of an old thing, and things started to conflict. So for me, it was not that convenient. But someone else, like a few weeks ago or a few months ago, came here to the AWS user group to convince everyone of using Terraform instead of CloudFormation. My point is, if AWS provide you with CloudFormation and also promise you of doing the rollback for you, managing your rollout and this kind of stuff, then CloudFormation is something better to use.
Yeah, thanks for your suggestion. Actually, I'm doing Terraform. Yeah, that's your suggestion is a good way to follow. Yeah, thanks.
Yep. Thank you for the question.
Thanks, Arafat, for the questions. Any other question, guys? You can ask Salam anything.
Anything?
This is your chance.
Ask Salam anything. AAA.
ASA. Yeah. Cool. Thank you, guys.
I have one question.
Yes, sure.
I was waiting for that, Fabian.
So Salam, earlier you brought up this one slide. You talk about microservices, and then you brought up the CAP theorem. How are they related?
Oh, that's a very good question. When you build a microservice, you build something called a distributed system, right? I think it's here. So you build a distributed system. Now, let me give you some example to show you what is the issue with building distributed system without knowing what you are dealing with. I believe that if you build a distributed system and then you say, okay, my distributed system will have an SLA which says that any request that is coming will be processed. So that means you give an availability promise. You say your system is available, right? And you also say, let's say that my system is going to be on all the time, right? So if I receive a request, let's say if I receive a request, I process it in the correct way, and then I return the result. Now, if you try to apply this in the real life, maybe your data won't be consistent. Maybe your data will be eventually consistent, right? Not strongly consistent. This is the idea.
Makes sense. Makes sense. Yep.
Yep.
Because when you talk about availability, typically what I end up doing, in a microservice environment is that I start thinking about asynchronous type of communication, and I think that's where the eventual consistency will actually come in.
Correct.
That makes a lot of sense. Yeah. Okay.
Correct. Thank you.
Awesome. Any last question, guys, for Salam?
One question.
Yeah.
Salam? Yes. One ask about just now. You said if the Lambda it will be consume more than 15 minutes, then you can use Fargate. Or so one thing new come out with the AWS for Lambda that you can do asynchronous. So like you can launch after one Lambda, like after it's asynchronous. So one Lambda you launch before the date, the time finish, then you can launch another Lambda. So is it like convenience or still Fargate is better?
That's a very good point. Actually, I think the way the way AWS schedule your Lambda to run is based on internal queue. So there is an internal queuing system that people don't see. The event comes to this queue, and then based on the quota you have from, let's say, your Lambda limits, I mean like resource limit on AWS, or the running Lambda, compared to the limits. If you have a free ability to have Lambda running, then your event is going to a Lambda function and then being processed. Now, let's put this picture here and think about having an API gateway. Your customer will send, click a button and then send a request. Your request will hit API gateway and then will be queued in this queue, and then we'll be waiting for your Lambda to pick it up and process it. Now, let's say your timeout is 30 seconds. If let's say you have 500 Lambdas that can run concurrently in your account, and you have 501 requests coming, then this 500 is blocking one of the requests, and this request will end up timing out. That's why I think the Lambda is not, it's not something that you would want to expose to your users if you have many user requests. Why I said some people would disagree with me, because some companies deal with this. They expose their APIs with Lambda, with API gateway and Lambda, and they don't face any issues because they have a low request rate. But then if you have many microservices, many people maybe under the same account, then you will face this again. Or if you have many worker mode Lambda function waking up and eating up your quota of Lambda function that can run concurrently, then your users are affected.
Yeah, I totally agree with Salam on this one. Actually, we faced similar problem where we hit the limit. So you can actually increase the limit from if you raise a ticket to AWS, but still, it takes time and your website is down until they increase the limit for you. So I totally agree with this, and I saw it like a couple of times actually, Lambdas hitting the limit. So it's kind of dangerous, I would say.
Yep. I had a very cool story during a DDoS attack in one of the companies I worked in, because we have most of our infrastructure running on Lambda function. Even our legitimate users couldn't access the system, just because the DDoS was DDoSing the rate of the Lambdas that you can have. Yeah, I hope I answered your question, Mustafa. If you want.
Yes, sure. Is there any statistic about the cost also, or is like? something that give more bigger picture that like if I follow the Lambda style, even I launch another Lambda, if I can like the number it's enough for me, or Fargate still more economical or cheaper?
I think Lambda is more economical. Like you get 2 million Lambda for free, right, every month. So for sure it's cheaper. It's just, again, maybe it relates somehow to the cap theorem in a way, because like, do you want your system to be available, or
Yeah.
you want something else?
Is there any round robin, something like called round robin or something like this technique that you handle the Lambda? You said like you have 1 million Lambda limit, then if you use this technique, round robin technique, then is it helping in these things or no?
I'm not sure about the round robin technique. Could you explain a little bit more?
Like for example, now you said if the Lambda will take half hour, for example. So I don't make the Lambda take half hour. I will run the Lambda like 10 minutes. Then I will jump to other Lambda that like this 1 million one. So the 1 million one, this number one extra than the million will take place. Then run 10 minutes. Then back to the one that queuing back.
Yep. So there is a concept called lambda chaining, which can help you with this. Yep. So lambda chaining allow you to say, let's say your event takes 1 hour to process, and you have maximum of 15 minutes of processing with every lambda. Then maybe you run 4 lambdas back to back to process your event. But then again, if you have an API gateway in front of the request, and you pass the first lambda, that's it. The result is returned to your customer. So if you are speaking about a worker mode, like let's say a background process, yes, what you mentioned would work. The lambda chaining would work.
Cool. Salam, you have Mustafa, you need to add anything?
So I was asking Salam this thing that if lambda chaining is it, then how is it different from step functions? Like we can achieve this with step functions too, right, Salam?
Yes, you could. If you manage the state outside of the step function, you could do like a loop, right? A loop like iterative code.
Okay, so then I have to manage the state outside, and in lambda chaining, it's just one state, and it's a concurrent set of functions which are executing.
You have to manage the state anyway. Like in both ways, you have to manage the state anyway. But what I'm saying is that you will manage it anyway inside step functions, or like on the scope of the whole step function architecture that you have, or on the scope of your lambda functions. It's the same thing in a way. Yeah.
Okay.
Cool. Salam, you have one question on the chat from David as well regarding rollback.
Let me read it. So, hi Salam, I have a question about microservice regarding the rollback happen between 2 services. Can you explain a little bit more, just so that I can answer correctly? Also drink some water.
Yeah, David, if you want to unmute yourself, you can do that as well.
Just because I don't understand correctly.
So I think what he means, let's say you have 2 services, microservices, right? And you deploy a new feature, for example, on one of the servers, and you made update on the second service, and you want now to roll back the first service deployment. So how do you do this rollback? Actually, it's a good question. Did I explain it correctly, David, or maybe you just can write? Yeah, he's saying yes, I think. Yeah.
Sorry, again, I'm just trying to understand correctly.
So what he's saying, let's say you have 2 microservices, right? And let's say you have a new feature. So you deploy a new feature on the first service and the second microservice using the first service, correct? And you made some changes as well. Okay. But you found there's a bug in this deployment, so you want to roll back. So how do you do the rollback?
I see. I think it's a very good question. In my opinion, right, and many people would disagree with me, that versioning is the correct way to do it if you are using a RESTful API. So you don't point your new service, like let's say you have service A and service B. Service B is consumer of service A. Service A have 3 versions running side to side, right? Because you have mobile application, let's say, connected to your service A. Now you rolled out service A version 3, right? And you point service B to service A version 3. Then if you find failure, you directly just roll back from a configuration point of view in your service B to version 2. Feature toggle is a cool implementation as well, Bilal. Yep. So feature toggle is a concept where you store your configuration in a way that people can modify, right? And then you could use this configuration actively in your code. Like you could check if this configuration value is equal this, then maybe point at specific version, or point or enable this feature or disable this feature. Yep. And feature toggle is also called testing in production. Like you could test in production if you like the risk.
Is it the same as feature flags as well, or different?
Correct.
Oh, okay.
I think AWS have a service for this, if I'm not mistaken.
What does it call?
So AWS have a service for managing configuration, if I'm not mistaken. Cloud config? Yeah, I think so.
Okay. Fabian, do you want to jump in on the rollback? Because actually I'm really interested as well on this.
So I actually put it into the chat already. If you're just talking about deployments, rolling back, how do you actually manage that? Because for me, deployments is all about risk management and user experience, right? And that's where we have code deploy, which integrates directly with the application load balancer. So in the event, like you are releasing a new feature, you will deploy, let's say, a new Fargate container. And what code deploy essentially will do is that it will move the traffic bit by bit over to the newly deployed container. So it's like 10%, 10%, 10%. And if there's any kind of errors, it automatically rolls back. So you can check out this service. In fact, Salam, just to let you know, I've been talking to Bara about this, right? How Seek goes about doing some of the implementation. Apparently, code deploy with the canary deployments is actually used.
Yes, correct. We are using Blue-Green, by the way. And when Canary came, our paved road team started implementing it. So yeah.
Cool. Okay.
There is a question: how to manage environment variable for 10K API effectively? I don't know if
10K APIs, as in you're talking about 10,000 REST APIs. Move to GraphQL.
10,000 APIs, right? This is how I understand it. So it's not 10,000 API code; it's 10,000 APIs.
10,000 APIs. Yeah, that's why I was thinking about GraphQL.
Yeah.
Yep. That's a single endpoint. Yeah.
Yep. Agree.
Cool. Okay, guys, we can take last question if you guys have any. If not, okay, Salam. I really like your presentation today, man. It was like a kind of different and open discussion. I really love it. So thanks, Salam, for joining us as a speaker today.
Thank you for listening to me, guys.
Yeah. Let me just share quickly as well. And again, guys, if you have any question to Salam or you want to ask him, he's a really helpful guy in the community. Just post it on Facebook group, and we will be happy to answer you as well. So, and now before we end up this meetup and go to our networking session where we can talk about anything, guys, we can talk about music, tech, anything you want. Please scan this QR code right now and just give us a feedback. What do you think we can do better? How we can improve this community, because this community for all of us, right? And again, Kaushik will help us to pick up some of the guys who will fill up this form, and you will get some free credits. You can use it to have fun on AWS. Okay, guys, so please just scan it and fill the thing. And don't forget as well to follow us on Facebook, YouTube, Meetup, and LinkedIn. I feel like I'm a YouTuber now. So I think that's it for today. We will stop the live now. We'll stop the streaming. And again, we can just open the cam, all of us, and chat. We have Bilal, who used to live in KL and work here, and he moved to Netherlands. He's working as solution architect, so you can ask him question if you want, how you can move over there if you want. Okay, guys, so thank you, everyone who's watching us through the stream, And let's go to the networking session.